What up, class? Hope you guys had a good weekend. We're gonna start a new chapter this week. It's basically on polynomial functions. Today we're learning about sketching graphs of polynomial functions. This is something that you'll learn a lot more in depth in calculus, but there are some things that we can figure out with just some algebra skills. So we're gonna get into that today. The topics that we're going to cover are degree of a polynomial, standard form versus factored form, and then we're going to do a polynomial function investigation. Just kind of look at like different types of graphs and see if we can come up with some patterns. And throughout that investigation, we're going to talk about just like what the degree of the polynomial function that we're looking at, its x-intercepts, turning points in the graph, and the ending directions of the graph. Okay, so let's remind ourselves what the degree of polynomial is. So it's important first to talk about the degree of a monomial. So we talked about, again, what a monomial was last week. So the degree of a monomial is the sum of the exponents of the variables. So let's just do a couple of examples. So degree 0 would be any number. So like 5. That's because 5 really can be written as 5 times x to the 0. So 0 is the degree of the exponent, right? Because x to the 0 is 1. So 5 times 1 is still 5. Now degree 1 it can look like lots of different things. Most common is it just looks like variable x because x has an exponent of 1, right? But it could also be y or 2z or 1/3 x. Basically any term that has, a variable degree 1. And then degree 2 most commonly is just x squared, right? Because the exponent is 2, but it could also look like negative y squared. Okay, this is all important. 4/5 xy, because the degree of a monomial is the sum of the exponents of the variable. So x has an exponent of 1, and y has an exponent of 1. So 4/5 xy is really 4/5 x to the 1, y to the 1, and the sum of that is still 2. So that's why this term is still degree 2. Degree 3 most commonly is x cubed, but you could also have like 5y cubed. And then again, if you have multiple variables in the term, you like 1/2 x squared y, right? That's degree 3 because the exponent of x is 2 and the exponent of y is 1, right? 2 plus 1 is 3. Or you could have 7xy squared. Degree 4, right? Most commonly is x to the 4th, but it could be like negative 8y to the 4th, 3/2 x squared y squared, right? Because the sum of the exponents is still 4, and then minus x cubed y, again, the sum of the exponents is y. Okay, so now that we got it covered what degree of a monomial, the degree of a polynomial is the highest of the degrees of the monomials with non-zero coefficients. Okay, so let's test if you understand. So what is degree of the following? So what is the degree of negative 1/2 x squared? That's right, degree 2. What's the degree of 100? That's right, degree 0. What about the polynomial x squared minus x plus 4? That's right, degree 2. Okay, what about the binomial 1 minus 3x? That's right, degree 1. Okay, what about x cubed minus 5x squared plus 4x minus 1? That's right, degree 3. Okay, here's a tricky one. What about 3 plus 9xy? That's right, degree 2. And lastly, what about 7x squared y plus 2y squared? That's right, degree 3, because 7x squared y has a degree 3, and that's the highest. Okay, so now that we figured out what degree is, let's go over standard form versus factored form. Okay, so functions can be written in multiple ways, as you know, like we've gone over like many ways to write a parabola, we've gone over many ways to write a line, and then and other functions that we've learned. So most commonly, the functions are either in standard form or factored form. So polynomials in standard form when it's an expanded form where the first term is the highest degree and the second term is the second highest, and so on. So let's give you an example so it makes that more clear. So the expanded form of just any function, we're gonna go is just like when it's written out as the sum of the following terms, like y equals 10x minus 3x squared minus 4x cubed plus x to the fourth plus 8. Now this isn't in standard form because the terms are not in order by degree, right? So like 10x, right, it has a degree of 1, and that is not the highest term on there. So if you were to rewrite it in standard form, right, x to the fourth would come first, and it would look like y equals x to the fourth minus 4x cubed minus 3x squared plus 10x plus 8. Okay, and now factored form, we're going to learn how to do some factorings in this chapter for these higher degree polynomials, right? We've only really been factoring like mostly quadratics, but we did a couple of cubics. Nothing too intense, but we're going to learn the higher ones in this chapter. But for now, I'll just tell you what the factored form of this polynomial is. It's y equals x plus 1 squared times the quantity of x minus 2 times the quantity of x minus 4. Okay, so just to prove to you that these are the same, if you expand x plus 1 squared, you're going to get x squared plus 2x plus 1. And if you expand x minus 2 times x minus 4, it would be x squared minus 6x plus 8. So you can see here, so there's x plus 1 squared, and then those two together is x squared minus 6x plus 8. So, right, we're on our way to expanding, so you multiply out the factors. Okay, so now we need to multiply these out. So you make this giant area model, right? So then, and then you just multiply each of them. So x squared times x squared is x to the fourth. X squared times negative 6x is negative 6x cubed. X squared times 8 is 8x squared. Then 2x times x squared is 2x cubed. 2x times negative 6x is negative 12x squared. And 2x times 8 is 16x. And then 1 times x squared is x squared. 1 times negative 6x, negative 6x. And 1 times 8 is 8. Okay, so then if you add up all the like terms, you get this function, x to the fourth minus 4x cubed minus 3x squared plus 10x plus 8. So now you can see the factor form is the same as the standard form. You see just highlight the like terms, like there's the x to the fourth. These are the two ones that have x cubed, so negative 6x cubed plus 2x cubed is negative 4x cubed. And then these are the ones that have x squared. These are all, so then 8x squared minus 12x squared plus x squared is negative 3x squared. These are the ones that degree 1, 16x minus 6x, that's 10x, and then lastly 8. Okay, So, um, okay, so the Mathematical and Carnival Company has decided to build a new roller coaster to use as this year's county fair. The new coaster will have a very special feature. Part of the ride will be underground. So the designers will use polynomial function to describe the different pieces of the track. So part of this design is shown here. So here's the roller coaster. Your task is basically to guess a possible equation to represent the track and test it on your graphing calculator. So to help get an idea of what to try, start by checking the graphs of the equations that I'm about to give you. Right? So here's polynomial. Let's just like look at this polynomial for a second. So this is really important. Um, it's x-intercepts are really important. So you notice it has three x-intercepts. It has 0, 2, and 3. The direction of the graph is really important. So it's called like end behavior. So if you notice, as you move on to negative infinity, right, the graph goes up to positive infinity. So on the left side, right, the graph is going to be forever pointing upwards. And then as you go towards positive infinity, the graph is going, y is increasing to positive infinity. So as you can see, the end behavior, the both of them are going to be like pointing up and to the right, forever. But in the middle, right, that's also important. What is going on in the middle? It has some humps and valleys, and we're going to call those like turning points. So there is a turning point right very bottom at the first one, and then that's a little valley, and then it does another turning point, and then another. So there are 3 turning points. Okay, so keep those in mind when we look at these functions. So we're going to look at this function here, y equals x times the quantity of x minus 2. So I said earlier you want to use these graphs to figure out what our equation for this roller coaster would be. So basically we just want to like what kinds of things do these graphs have that our roller coaster also has. So here obviously this is a parabola, so definitely not the roller coaster. But what does it have in common? It has the end behavior is the same, right? They're both pointing in the same direction, the end, both pointing up, and it has 2 x-intercepts that they have in common, right? So this one, the roller coaster that we have has 3, so the parabola is really missing that third x-intercept that we want, the x-intercept of 3. Okay, now let's look at this graph. X times x minus 2 squared. Okay, so this is degree 3 because x is degree 1, and then if you multiply by x minus 2 squared, then you add 2 more to the degree. So let's see what these have in common. So that graph looks like this. It's a cubic function. It also has the x-intercepts that we want, 0 and 2, but it's still missing the x-intercept 3. The end behavior is not the same, but we do have more turning points. So the parabola that we first graphed only had 1 turning point, and we need 3, right? And this one now has 2 turning points. So it's getting a little more like the roller coaster that we want. Let's look at this last graph and see if we can come up with a function for our roller coaster. Okay, so this is also a cubic, and right, because x is x times x minus 2 times x minus 3, it's like 3 products, so then that's the degree. It looks like this. Okay, now it finally does have all the x-intercepts that we want. It has the x-intercept 0, 2, and 3. The end behavior is not the same either, and the turning points isn't the same, but we do have number of turning points. Okay, let's see if we can get everything that we want. So Um, let's see if you can guess what it is. Okay, so it's y equals x times x minus 2 squared times x minus 3. Right, now this graph is degree 4. The end behavior now is the same. Now it's important, and we'll talk about this in the next couple of slides. But when you have like these factors, it tells you what the x-intercepts are, and then if the factor is repeated, so if you notice in the second graph on the left, right, y equals x minus 2 squared, the graph hits 2, but it bounces back up, right? So, and then for the third graph, right, it just has x minus 2 and not repeated, and it goes through x minus 2. So when the graph's factors are not repeated, the graph goes through the x-axis, and if it's repeated, it bounces at 2. So that's what we want. As you can see, we have like a turning point at 2, it bouncing on the x-axis. So that is the correct equation. Okay, let's look at some. So we're kind of going to break it down into we're going to look at 8 different functions, and we're going to look at like what their form is, what their degree is, what their graph is, and then like the number of x-intercepts, what they are, turning points, and directions. Just see if we can come up with some kind of like summary of like what all that stuff means. So this first function is x minus 2 times x plus 5 squared. Okay, so it's in factored form. Now the degree is basically when it's in factored form, you just want to like how many factors are there, right? There's one factor of x minus 2 and 2 factors of x plus 5. So the degree is 3. So and then the graph looks like this. So the number of x-intercepts, it has 2 x-intercepts, right? They are 2 and negative 5. So like I said before, x plus 5 squared is a repeated factor. So you notice that the graph comes up to negative 5 and then hits negative 5 on the x-axis and bounces back down. Okay, so that's really important. And then it goes through 2. The number of turning points, it goes up, then turns one time, and then turns again. So there are 2 turning points. And the end directions look like this. As you go to negative infinity, it's negative infinity, and as you go to positive infinity, y goes to positive infinity. Okay, let's look at another graph. So this 2 times x minus 2 times x plus 2 times x minus 3. This is in factored form. It's degree 3 as well. This is what the graph looks like. So this one has 3 x-intercepts, right? So the x-intercepts are, and as you notice, right, like you're going to have, like I said, since there are no repeated factors, they go through all the x-intercepts. The x-intercepts are negative 2, 2, and 3, and the amount of turning points is also 2, and the end behavior is the same as the last graph. Okay, so that's important, right? The end behavior and the number of turning points are both the same for these two graphs. What do these two graphs have in common? Their degree. So they're both cubic, so it's important to notice they both have the same amount of turning points and the same end behavior. So the shape of these two graphs generally look the same because they are both cubics. Okay, let's look at this other graph. This is x to the 4. This is not in factored form. This is in standard form. And you're going to realize it's standard form, although it looks nice, doesn't give you a whole lot of information about what the graph looks like. right? So in the previous one, the factored forms, the numbers in the factors are related to the x-intercepts. Like I said, standard, the coefficients and standard and all that stuff. It doesn't give you a whole lot of information about the graph. So this is degree 4. This one looks kind of cool. It looks like this. The number of x-intercepts is 4. The x-intercepts are negative 5, 0, 1, and 4. The number of turning points is 3. And the end behavior as x goes to negative infinity, y goes to positive infinity, and as x goes to positive infinity, y goes to positive infinity. So you have this direction here. So let's see what's important. So if the degree goes up, so now the first two graphs are cubics, and now this is a quartic. Now the number of x-intercepts have gone up, the number of turning points have gone up. So you can see the degree is related to number of x-intercepts and the turning points. Okay, let's look at this next graph. This is in factored form. This is degree 5, okay? This is a quintic graph. So exciting. So, the graph looks like this. So it has 4 x-intercepts. So this is important. So you can see there's 4 distinct factors, right? X plus 3, x plus 1, x minus 1, and x minus 5. But x plus 3, right, is what's called a repeated factor, right? Because it has an exponent of 2. So that's why it only has 4 x-intercepts. And it's important to notice what happens at the repeated ones. So negative 3 is the repeated x-intercept. As you can see, the graph comes up from the left and hits the x-axis at negative 3 and then bounces back down. So on repeated factors, the graph does not go through the x-axis, it bounces on the x-axis. So negative 3, negative 1, 1, and 5 are the x-intercepts. The number of turning points is 4, right? So like I said, the degree of the polynomial is related to how many x-intercepts you have and also the turning points. It's also related to end behavior, and we'll talk about that when we go to summary. End behavior, this one, right, as x goes to negative infinity, y goes to negative infinity, x goes to positive infinity, y goes to positive infinity. Okay, so like I said, we're going to go over 8 total functions. You have 4 more. So here we go. So next function, negative 0.1 times x plus 4 cubed. This is in factored form and it's degree 4. Right, x plus 4 is a repeated factor 3 times. So this graph looks like this. Okay, so as you notice, as I said before, it bounces when you have a repeated factor. Well, this is repeated and it's not bouncing, but it is doing something else, right? It's kind of changing, it's like kind of changing, like, it's the way it's going up, right? It's kind of like going up and then slowing down at negative 4 when it hits the x-axis, and then now it's increasing again. It has 2 x-intercepts, and they're negative 0 and 4, or negative 0, geez, negative 4 and 0, and there's only 1 turning point. So at negative 4, it's not actually turning, it's not actually a valley or a hill, but you'll learn about them in calculus, like I said, but it's called an inflection point when it does that. And the end behavior as x goes to negative infinity. So this is interesting. So far, the ones that have been going the same direction, beginning and end, have both been going up. This one, they're both going down. So as x goes to negative infinity, y goes to negative infinity. As x goes to positive infinity, y goes to negative infinity. Okay, let's look at this graph. X to the fourth minus 9x squared. This is in standard form and it's degree 4. Okay, this one looks like this. The number of x-intercepts is 3. Not obvious what they are because this isn't in, from the function because it's not in factored form, but from the graph it's negative 3, 0, and 3. The turning point is 3. And the end direction is x goes to positive infinity. It's positive infinity. X goes to negative infinity. It's negative infinity. Okay, second to last one. I'm hoping you see some patterns here. If you don't see any patterns yet, then it's really important that you're paying attention during now and the summary, of course. So this is 0.2x times x plus 1 times x minus 3 x plus 4. So it's factor form, which helps. The number of factors are 4, so it's degree 4. And there are no repeated factors. So here it is. Looks like this. As you can see, like the last one with degree 4, it kind of had a W shape. This one also has like a W shape, right? That's because the degree affects the number of turning points. So the number of x-intercepts is 4. And they are negative 4, negative 1, 0, and 3. The turning points is 3, and you hand me where it looks like this. Okay, last one. X to the fourth minus 4x cubed minus 3x squared plus 10x plus 8. Okay, so this is the first function they were talking about. We were talking about standard form versus factored form. So this is in standard form. It's degree 4. Kind of a wobbly W. It has 3 x-intercepts. That's because if you recall from factored form, x plus 1 is a repeated factor, so it bounces there. So it has the x-intercepts, negative 1, 2, and 4. Turning points is 3, and behavior is like this. Okay, let's go over the summary. So degree of a polynomial, remember, it's the highest, it's the degree of a polynomial is whatever the degree of the term of the polynomial that has the highest. Standard form versus factor form. Standard form is in expanded form and descending degree, and factored form is written as a product of factors, right? From the polynomial investigation, right, we talked about how the degree affects the graph, and how the x-intercepts, turning points, and end direction. So if we're going to give this example here, the degree is basically how many factors you have. So you add up all the factors. So in this, like you count the exponents and count how many factors are, and that's the degree. The x-intercepts are where each factor is equal to 0. So in this case, like D and C. Okay, and it's important. So if n is so if you have a repeated factor like x minus d to the n, if n is even, so if the exponent of the repeated factor is even, it bounces. And if it's odd, it kind of does that weird like S swivel through it, right? Which I said is called an inflection point. You'll learn that in calculus, but so it's important for repeated factors to know the difference. And then for turning points, the turning points is affected by the degree. The number of turning points is up to the degree of the polynomial minus 1. And then x-intercepts can be up to the degree of the polynomial. So if the degree is 4, you can have basically up to 4 x-intercepts and 3 turning points. Okay, and then the n directions are based on two things. It's based on if the degree of the polynomial is even or odd, and then if the leading coefficient of the polynomial, like in standard form, is positive or negative. So, for instance, if the degree is even, right, and the leading coefficient is positive, then they both go up. And if it's negative, then they both go down. And then if the degree is odd, then it goes down, then up if it's positive. And then if the degree is odd and leading coefficient is negative, then it goes up, then down. Okay, so that's it for today. Hopefully you've gathered enough information so you can finish the homework. See you later.